Hello everyone, my name is Ishan and I am today presenting the topic real-time voice command rig control using Deeepgram SDK. So in this video, I will give the code explanation and the presentation of the app. So first of all, introduction of Liquid Galaxy. So Liquid Galaxy is an enormous, immersive, panoramic viewing system allowing users to view Google Earth using system different. It follows the master-slave architecture, where one master system controls all the connected displays. And Liquid Galaxy is widely used for data visualization, education, exhibition, tourism, and smart city demonstration. Since it is open source and collaborative, it allows developers to build new interaction methods on top of it. This is where the project fits. So moving on to the next slide. So how LG is commonly controlled. So LG is commonly controlled as the master slave architecture, and we are echoing the command of kernel through static kernel. So it is controlled mainly using the mouse keyboard connection for another input devices and predefined kernel script. So technically they are good, but they are not hand-free, they are not intuitive, they are not immersive. So for non-technical users, it becomes a very difficult task to control this LG systems. And it also increases the dependency on the manual operator. As a result, more setup requires a trained operator to understand systems and commands. Then So we introduce a new feature which is called voice command control. So it will use our voice and natural voice like command to control the rate, and it will gives us a real time experience. So to solve these limitations, instead of clicking or typing, the user can simply speak or say commands like fly to Paris, fly to Delhi, zoom in, shut down, fix, etc. And the application captures using microphone input. And using Deeepgram SDK, which is a labeling pattern, it will get converted to the text, and then the command will go on. So moving on to the Deeepgram SDK. So Deeepgram SDK I have used because it is for converting the real-time speech to text output. So it has low latency, high accuracy in the system, and also support for streaming audio. Means if we are using Deeepgram API, we can just simply say anything and it will be passed to the text automatically. Using the pub.dev Flutter SDK. It is also easy to install it in the Flutter system, and also it works well for command-based systems and technical queries, which is important for precise responses. Then, then moving on to the functionality of that. So we will connect the LJ rig using SSH after entering the credentials like IP, username, host password, then port, and then number of rigs. And we will use guard SSH to connect this. Then on the home screen, the user will get a microphone button, and he or she will speak the command, and it will be sent to the Deeepgram itself, which will get converted to the text, and the output will be received by the app, and application passes it and maps the command to it, and Google Earth listens the command using echoing command, and then the desired output will be stored to the rig. Whole process is real time, and it will be stored to the user in the real time feedback. So before moving on to the code explanation, let's get on to the working demonstration of the app. To create this, I am using the Pixel 6 Pro API 35 version, and here as you can see the rig is synced successfully, and here is the app. So first display the title as well as commander. Here is the connection status tab, and from display a microphone recording button which says hold to record, then two bottom tabs, voice control and connection. So first we will connect the rig. So it uses shared preferences. So as I have entered the details before, it will get saved to the uh, device and it will get connected on clicking on the connector. So let's connect it. It will get connected and the status will change to connected. Then on going to the voice control, and here we will see say fly to Paris command to move the camera to the Paris location. So let's do that.
Fly to Paris.
Let's do it again.
Fly to Paris.
So it will recognize the command and Deeepgram will send the OK signal to move forward. Then it will fly to the Paris location. And as you can see, this is the Paris location displayed in the algorithm in the real time. So it will become a real-time communication method to do the things easily, immersively, and intuitively. Also for the non-technical users and for the people who are new into the system. So it acts as a well-developed command or well-developed community to be built by introducing this feature. So
Okay, so before moving on to the code explanation, let's see the file structure of the app. My app contains a basic connection model which is used to connect the LG rig to the app using SSH2 service. Then we have connection page. Then we have home page. Then we have LG service, which is a singleton service to hold all the functions. Then we have main.dart to root the apps. Then going on to the dependencies used in the pubspec.yaml. So we are using Flutter SDK, then Dart SSH2 for SSH communication for connecting the rig to the app using SSH client. Then we are using shared preferences to store the details of the connection in the app. Then we have Deeepgram speech to text pub.dev package which is used for converting the audio to the text using the API. And we have permission handler and sound stream. Permission handler for enabling the microphone permissions in the app, and the sound stream to just receive the audio. Each dependency is a project is purpose driven and directly supports secure, fast and friendly communication with the algorithm. So it promotes the good services used in the Liquid Galaxy. Moving on to the first file, which is lgservice.dart. So first we have imported asynchronous library which ensures the connection should be run in the backend thread, so it will not get involved with the UI and does not get crashed. Then we have Dart SSH2 package, then we have shared premises package. So first of all, we are creating a singleton LG service class with a private constructor, and we are initializing the SSH client, share preferences, and a controller to control the stream of the connection. Means that we are preserving the connection state. Okay, so we are also using connection status. For that purpose we are preserving the connection, and if it is get connected, the boolean will be get converted to the true or false. That will require bool get is connected. Then we have hard coded the cities for now, because for real time updates it will use Google Maps integration, and also some AI features to detect the command and search automatically through all commands, irrespective of the database I have provided. So since I have hard coded it, so it will contain New York, Paris, Tokyo, London, Sydney, India, Barcelona, Dubai, and San Francisco. These are the values fetched from the internet, and the latitudes and longitudes are marked in such a way that the camera location should be properly visible, and it can be tell that it is that location in which the location is pointing. Like in the Paris I have shown, the camera is moved to the center of the city, which is because of the altitude and the degrees. Then we have init function, which asynchronously initialize the shared preferences. Then to connect the LG rig and to also store the shared preferences, we are using connection model, which stores IP, username, password into integers, port number and rig number into integers, and before into strings. By default, the port is 22 SSH port, which is suitable for most of the Liquid Galaxy rigs. Then we have minimum number of rigs to be 3. It can be 5 or variable according to your system. Then we are creating also a factory to make the use case easy for the shared preferences. Moving on to the first function, which is connect. So connect function will fetch the IP user pass and pass port from the shared preferences stored tab, and if it is not null, it will try this block, and if it is null, it will return false. So when after in trying this block, it will create a SSH socket dot connect, and it will pass all the necessary informations like IP and port. Then it will run for the duration of 5 seconds so that connection does not get cancelled, and in the SSH client it will pass socket username and all password request, which will get the two connected to the LGRIP. Then on get connected, it will run the permissions chmod 777 to request the LGRIP to give the permissions to override the content. Then on the connection stream, the boolean we have created, we will add the function to true. If it is throwing error, we will print LG connection failed in the debug console, and we will get connection stream as false. Then in the disconnect function, we are asynchronously closing the SSH client, making it to null, and also making connection stream to also null. So the connection tab gets changed. Moving on to the next function, which is processing voice command, which the voice is receiving from the app. So first we will pass in the argument as string speech text, which will we get from API, and the raw text is converted to the lower text, and the spaces will be trimmed, so no problem occurs in the sending to the LGRIP. In debug console, we will print processing command along with the raw text, and we will loop all this city database, the list I have created for the cities like New York, Tokyo, London, and Paris. And if the raw text contains city in that string, so we will print in debug console the found city, and if it is connected, we will check the SSH connection first. If it is connected, then we will change the connection boolean to connect, and if it's not, we will return connection failed. And if it is connected, then we will go to try block and await a fly to city function, which is described later. And also we will returning the string flying to city name, which is displayed on the home screen as I have showed in the app demonstration. And if it is not, it will return the fly error string in the debug console. And if this raw text contains clean or stop, the clean KML function will work. It will work according to your use case, like any orbiting is going on or any KML is sent and you want to clean it. So this function is also there. And if you want to turn on the orbit, and the raw text means the text coming from the API contains the term orbit, so it will start the send orbit function. So it will basically work as like if you are just saying the city name, like if someone's accent is different or some other challenges happening in the microphone or some speech issues, so you are just saying the city name like Paris, India, Delhi, New York, Tokyo, London, anything. So it will recognize that city name. We are not searching like fly to Paris as a whole command. We are searching the city name, or like in the clean command, like in the stop command, we are not searching that clean KML, stop the rig. We are focusing on the main keyword so that the navigation is easier and immersive also. So this is the plus point of using voice commands. Then we have basic LG functions like execute to process the command. Like if it is get connected, we will call the await function, and if it's not, we will try to run the command. And if it throws error, we will print the execution failed, and we will disconnect the SSH client. A fly to city function, which we are calling after searching the city name. So fly to city function will do what? It will extract the data from the city database list I have created, and then extracting it, we will set longitude as first element, second element, latitude as first element, the range in which the camera will show, it will the third element, and then we have tilt in the fourth element, and the heading to display in the fifth element. And altitude mode is relative to seafloor, so we will get a shifted perspective to it, and we will run a look at command and also echo it to the LGRIP. This function holds the whole parsing logic of converting the text to the KML. Then we have clean camel function, which equals the empty camel. Then we have send orbit function, which equals the play to orbit. It is also be stopped using saying the command stop. Then we have save setting functions, which initializes the init block, and then set the strings which we are entered to the shared preferences, and otherwise set it to null if not provided. Moving on to next screen, which is connection screen.dart. So connection screen.dart looks like this, as we have shown earlier. So, first of all, it imports the material.dart package, which is used to design the UI. Then we have lgservice.dart to access all the functions. It extends the stateful widget to listen to the changes like connected disconnected tab, and also sending the forms controller to the state preferences. Then we have initialized the global form key to be accessed to the all screens. Then we have some form controllers like IP controller, user controller, the pass controller, port controller, and the controller to store and edit the text present. Then we have Boolean office loading to the false, so it will show us the loader on while connecting. Then we have initialized the controllers and also use the functions load setting to load the settings from the shared preferences as we have defined in LG service. Then we have disposed all the controllers if needed, and we have load settings functions which require LG service instance of init block, and if it is mounted or if it is get initialized, then we will put that text into the fields. We have handle connect function which says if the form is valid, means the text is edited and all the things are valid, means is loading is also true, then we will call the LG service instance and the save settings function to save the connection settings to the device, and we will change the success boolean variable to connect, and if it is get mounted, we will show the connection successful, and the snack bar color will be green, and if it is not, the snack bar color will be red, and we will show connection connection failed, check IP pass. Then we have handle disconnect function also, which uses this button, and on pressing it, it will disconnect from the SSH client using the LG service function, and also show a snack bar of disconnect. Then we have built the widgets like connection settings as title, then a form, then a column holding the all forms, and then stream builder, cards, and everything. We have this connected and disconnected text, and we are having ready to send commands and connect to control rings, changed on the basis of connection status. Then we have rig credentials like master IP address. If it is not in the type of number or empty, we will show the required validator. Then we have username, then we have password, then we have SSH port, which by default is 22, number of rigs which by default is 3, so we don't have to require validator there. Then on pressing the connect button, we will use the handle connect function with the loader. Then we have disconnected function, and here we are calling handle disconnect function on press. Moving on to the home screen.dart, we are having the LG voice commander as a title, and all things I have shown. So let's move on to the code explanation. So we are firstly importing Dart asynchronous library, then material.dart permission handler to control the voice permissions and send the request to enable the voice permissions. Then we have sound stream to listen to it, Deeepgram speech to text library, then LG service. So we are also creating stateful widgets here, so since we have to change the connection status and also the mic to listening mode. Then it says the hold mic to speak and is listening boolean variable to false. Also we have mic color, which is changing on holding and dropping, so it's also require a color variable. Then we have initialized the recorder stream, which is Deeepgram recorder stream, and also we have initialized the Deeepgram subscription model. Or I have created a temporary API key to test this app or the demo app. So this is the API key. We should keep it as environment variable, but for demonstration purposes, I am showing it. and it is the speech to text API key. Then we have init state and calling it lgservice.init and also init audio method, which will be described later. So init audio method will initialize the recorder, and Deepgram will pass the API key, so it will also get initialized. We have dispose all the subscriptions, and we have start listening function, which is our main function. So first of all, we are giving permission to microphone, if checking if the microphone permissions are there or not. So if not, we are displaying microphone permissions denied, and if it is true, we are setting the state to the microphone color red and the status text to listening. The status text is the text displayed at the top of the microphone. This is the status text, which is changing to the listening on holding the microphone. Then we are trying in this block the mic stream, which is recording the audio, and the recording is sent to the this dynamic model, which is Nova 2 general model of the Deepgram, having language English, encoding the form of linear 16 and sample rate of 16,000 bits. Interim results 2 means we are cancelling the background noise to the some extent, but we can't use that in the free version so much. So setting the audio subscription to this mic stream also, and the query which I have created in this parameters folder, it will all get sent to the Deepgram API, and if it is not null, we will get the status text back, and we will set it to response.transcript, which I have shown in the LG service that it is flying to, and in next bracket we have city name. So if it is also final, which boolean we will get from the Deepgram API, like here if it is final, then we will print the final sentence, and we will handle the voice result, which I will explain later. And if it is not, we will show the error message which is occurred to the API. Then we have a stop listening function, which is called on releasing the microphone button, which will stop the recorder and cancel the subscription. So handle voice result function calls process voice command function of the LG service, I have told, and if it is response is not null and it shows mounted, that is connection is done, so the status text will show the response. Then we have the widgets for building it. So on title, as I have shown, the LG voice commander, then stream builder for changing the connections of the connected tab. If it is connected, it will show LG connected, and not, then disconnected. Then we have the gesture detector of long press button, which on long press shows the start listening function of this particular class, and on long press down means releasing the long press or lifting the finger up, it will show stop listening, and it will on ending also calling stop listening function. It shows hold to record as a text. Then we have moving on to the class file, which is main.dart file. So importing the package flutter material dot, then we have home page.dart, connection page, and services. This main.dart file will act as the theme definition file. Then we have init state, and we have initialized the bottom nav here for the two tabs, which is home stream and the connection stream. So it will use the current index to move to the different streams. So summary of the presentation and the making of this app is to use the LG rig using voice controls, and presenting it in a way that it becomes immersive, intuitive, and easy to use, efficient also to all the users, irrespective of their technical abilities or their knowledge to the LG systems or rigs, making it important for any age group people and any knowledge people to explore the Liquid Galaxy Google Earth system. Thank you.